Morning class. This is Mr. Roberts at Shasta High School. Today we are looking at section 3.1.5, and the title for today is The Shape Factory. The Shape Factory. And you are going to be using the Shape Factory floor to create a catalog of possible shapes. Possible shapes. Again, a totally fictitious company. However, unlike the line company, I could see this actually happening. I could see ordering, you know, plates, aluminum or plate steel that is cut in these shapes, or even, very thick cardstock. This could happen. The Shape Factory is a company, and they've decided to branch out to include new shapes. You, my friend, and perhaps a good idea today would be to actually work on this in groups. Think about people that you sit with in class and maybe invite each other to work on the catalog together. But as a product developer, your team is responsible for finding new shapes. It says exciting, I don't know about that, but finding new shapes to offer customers. The current company catalog is shown at the right. That's all we have. We have a half square, an equilateral triangle, the half equilateral triangle, and we have an obtuse triangle. Since your boss is concerned about production cost, you want to avoid buying new machines and instead want to reprogram your current machines. The factory machines can not only make all the shapes shown in this catalog, but they're also able to rotate or reflect the shape exactly one time. For example, if the half equilateral triangle is rotated 180 degrees, let's see, the half equilateral triangle is rotated 180 degrees about the midpoint, that is the middle of its longest side, as shown at right, the result is a rectangle. Oh, yeah, I can see this. If I took this shape right here and rotated it 180 degrees about the longest side, I could get a rectangle. In fact, let's take a look at that in the Shape Factory. So this is the Shape Factory floor. And when you click this tool, this is going to allow you to pan around in the graphics view. So with this on, I can click and move around. Here is, now I'm just scrolling up to zoom into it, here is our half equilateral triangle. So this is an equilateral triangle cut in half. The distance from here to here, if I double that, I would get the distance from here to here. Because think about it, imagine there's an equilateral triangle and I cut off half of it. I have provided you with a tool to get the midpoint of any side. So this is the midpoint tool. And if you just click on the midpoint tool, if you come over and click, there is a midpoint labeled N. And just like the example in the book showed, if I take that and rotate, here's my rotation tool, I'm going to rotate this polygon, this half equilateral triangle, around this midpoint, and I'm going to do so for 180 degrees. And when I do that, I now have a beautiful rectangle. So let's continue down here. Your task. Your boss is giving your team until the end of this lesson to find as many new shapes as you can. Your team's reputation, which has suffered recently from a series of blunders, could really benefit from an impressive new line of shape formed by a triangle and its transformation. For each triangle in the catalog, determine which new shapes are created when it is rotated or reflected exactly one time. Okay, so you can only do one transformation, so that the image shares an entire side with the original triangle. So that's an important idea. It has to share an entire side with the original shape, so you can't offset things. Be sure to make as many new shapes as possible. Use tracing paper. No, we're going to be using GeoGebra instead. We're going to be using the factory floor. So if I come back and I look at this, let's go ahead and grab that one shape, the rectangle. Here it is. I can grab this and put it into the catalog. So I think most of you know how to copy images on a Chromebook. It's Control Shift and then the window key. But if I hit Control in my computer, I'm going to do my procedure. So I've just grabbed this wonderful rectangle, and now I'm going to go to the catalog. So this is where you'll be recording your work, and for each shape I want you to have an image of the shape. I want you to give it a name. Try to be as mathematical as possible. Give it what you think is the best name. If you have a shape and you're not sure about the name, then maybe look it up, do a little bit of research. But I'm going to go ahead and paste the shape in here. That's a little bit too big for the catalog, so be prepared to rescale these. That's more than adequate. I will call this a rectangle. And the thing I'm thinking about is I know that this down here had to be a right angle, and when I reflect it, this had to be a right angle. And these angles, if this is a right angle, these two little angles had to add up to 90. So I think this angle plus that are 90. So this is a rectangle. It has two pairs of parallel sides. And I could make this sound more flowery, but it has two wonderful pairs of parallel sides. And each pair of parallel sides are congruent, or I'll say equal in length, EQU, equal in length. It has 4 right angles, and I think I'll leave it there. There's probably more things we can say about it, but there, that's a rectangle in our catalog. Moving on. You don't need to include the 4 given shapes. We're just looking for new ones that aren't currently in the catalog. So again, let's go back to the factory floor. So when you're here, again, you can zoom out, and if you need to, whoops, I don't want to do that. If you need to get to a place where, okay, I've played with that and I need to reset it, you can always just reload the page. If you reload the page, it'll come back to this exact setting, and then you are prepared to begin again. And for each of the shapes, I have given you the necessary tools. So for example, you can reflect a polygon across one of its sides. So if I wanted to, this is our reflection tool. I could say I want to reflect this polygon across this side. Ooh. I could reflect this polygon across this side. So you can see that there's this polygon across this side. So by doing reflections, there's certain polygons we can get. And then there's also the rotation bit. So I think we need to rotate around midpoints, but like I'm willing to try this. Like if I say let's rotate this around this point, and I'll do that 180 degrees. Yeah, see, the problem with this is that this shape does not share an entire side from the original shape. So because it doesn't share an entire side length from the original shape, this is not something that we're capable of producing. Although I liked it. But I could grab the midpoint here, and I could rotate this thing. I could do a rotation of this polygon around that midpoint, again 180 degrees. And when I do that, I get this. Yeah, that could be something. So I'm not going to look at a lot more of them, but I want you to play with both the reflections and the rotations around midpoints and build out a catalog, as big a catalog as you can. I'm looking for as many unique shapes as possible. And when you are done, if you are working together, make sure you copy the final product that you've produced, paste that into your catalog, and submit the one that you've all worked on together. So as you're working today, if you feel like you're a little stuck and you're not sure what to do, I would suggest looking at question 52. These are optional. Really, the product I'm looking for is the catalog. And if you have an image, an appropriate name, and a description of each of the polygons you come up, that's good. But if you're stuck, look at 52, A, B, and C. That'll give you some ideas of things you might want to try. as you kind of exhaust the possibilities with the one reflection or the one rotation, I would like for you to add to your catalog and maybe say this shape is not yet available, but I want you to think about some shapes that could be possible if you can add some extra functionality or buy new machines. So for example, what if you reflected the equilateral triangle twice, once across one side and another time across a different side? So play with the equilateral triangle, see what you can get with that. What if an equilateral triangle is repeatedly rotate about one vertex so that each resulting triangle shares one side with another until the new triangles are no longer until new triangles are no longer possible? Describe the shape. That would be a really fun one to look at if you've got that. So read that a couple times and then get into the factory floor and try to play with that. And then finally, what if you rotated a trapezoid 180 degrees around the midpoint of one of its non-parallel sides? So I do not have a trapezoid set up for you. So if you're going to do that, you might want to look at a fresh version of GeoGebra on the web, or maybe do it with some patty paper. That one is not required, but I would really like to see you extend out with the first two bulleted items. And of course, as you're working, you will be building a catalog as you go. So it's not like you're going to have to do this as a special thing at the end. But your boss needs you to create a catalog page that includes your shapes, and it can be multiple pages. Each entry should include a diagram, a name, and a description of the shape. List any special features of the shape, such as any sides of the same length, or any angles that must be equal. Use color and arrows to highlight these attributes in the diagrams. And one thing you can also do is in your Chromebooks, if you want to, you can take some shapes, bring it over to a paint program, and kind of mark up that shape a little bit if you want to pull out or highlight some special features, and then put that in the catalog. All right, so that's it. That's what we're doing today. We are building a catalog, and I hope you have a good day. If you need to talk to me, I will be doing a training for most of the morning. I will have the meeting up, and I'll put on there a time that I'm intending to come, but the district's asked me to do a training today on something else. But I think by 11:30 or maybe 12:30 I will be done, and I'll just open up a session and keep it open all day long. So if you have any questions or you're stuck with things, stop in and talk to me. This is Mr. Roberts. Hope you have a great day. Look forward to seeing you on campus and online soon.